All right, so let's take a look at example 3. It says Ken has 1,200 meters of fence to put around 2 rectangular yards. If the yards are to be separated by part of a fence, what would be the length and width for the maximum area? Okay, so again, these type of word problems, they don't give you one number, and you really just have to be able to draw the picture and set up the equations. Okay, so the picture is already provided for you, and the easiest way I find to do this problem, right, is just simply call this the width, and then call this whole thing the length, right? And so if you want to maximize this area, right, your equation would be very, very straightforward, right? The equation, if I want to maximize the area, and I'm just going to leave it in parentheses because this is where I want to maximize, is just width times length, right? Sometimes students, they like to, have multiple, call this guy right here an L, call this guy right here an L, but just call it a single L, right? All right, so that's what we want to maximize. We want to maximize the area. And that second equation, right? Like, how would I set up my second equation? Well, Ken only has 1,200 meters of fence to work with. That means the perimeter of this configuration, right, is 1,200 meters. Okay, so how would you write the perimeter? Well, this one is W, this one's W, right? And this guy right here is L. You would say 2L plus 3W is equal to 1,200. Okay, because he's trying to make a fence, right? So you have to include that middle W. And, after doing some of these problems, right, you hopefully can see a pattern. You set up 2 equations. One equation, you're going to maximize or minimize. The other equation, you need to get one of the variables by themselves, right? And then substitute. Okay, so for no other rhyme or reason, I'm going to put this as a function of W. If you want to put it as a function of L, you're welcome to. So if I want to put it as a function of W, right, I need to get this equation with L by itself. Okay, so let's do that. 2L is equal to 1,200 minus 3W. Divide both sides by 2. You're going to get L is equal to 600 minus 3 over 2W. And then you substitute. Okay, so now if you take a look, right, everything is a function of the width. And if you want to find the if you want to find the width and length for maximum area, right, you need to find the vertex. Now, in the first 2 examples, right, in example 1 and 2, basically I used x is equal to negative b over 2a. For this one, I'm just going to use the intercept form equation. Okay, so the way you use the intercept form vertex formula is you get your x-intercepts, right? W is equal to 0, or 600 minus 3 over 2W is equal to 0. So one of my x-intercepts is 0. This one, if you solve really quickly, right, multiply both sides by 2/3. 1,200 over 3 will give you 400, right? Okay, so is that it? My width is 400? No. The formula, right, is P plus Q over 2. So 0 plus 400, divide by 2 because it's the midpoint. The width should be 200 and 200 meters, right? To get the length, you plug this guy back into here. Okay, so 600 minus 3 over 2 times 200. Over here, you're going to get 100. 600 minus 300, of course, is 300 meters. Okay, so these are the dimensions that will give you the maximum area. If I ask you what is the maximum area, right, you would just multiply. The maximum area is 60,000, right, meters squared. Okay, so these are the dimensions, but it didn't really ask you for the maximum area. But if it did, sometimes there, those problems, another part of the problem will ask you what is the max, and you already did all the work. You could just multiply it. All right, so I'm going to skip number 4. I want you guys to try that. I'm going to move on to number 5. There's one last type of problem that you'll encounter in your homework. And these are kind of what I call revenue problems. Again, you'll find them in any Math 3, Algebra 2 textbook. But if you've never seen it in Algebra 2 or Math 3, you're seeing it here for the first time, it's not that big of a deal. Okay, so if you take a look, it says a store sells about 40 video games each month when it charges $200 per system. For each $10 increase in price, about one less system per month is sold. What should the store charge to maximize revenue? What is the maximum revenue? Okay, so again, think optimization, think, vertex, but this one, you need an equation, right? Just like you need an equation from the previous examples, okay? So if I ask you, revenue, what is revenue? Revenue, right, is simply, the quantity, right, times the price per quantity, okay? So how much a store sells times the price for that particular quantity, right? And so in this particular problem, right, the store sells 40 video games systems, and the price that they currently charge is $200. Okay, so if I ask you, what's the revenue, right? You would just say 40 times 200, which is $8,000, right? The store brings in $8,000. Okay, but what about the second sentence? It says, for each $10 increase in price, one less system per month is sold. So here is the key to the problem. You want to let X equal the number of times you increase the price by $10. Okay, so X is the number of times I increase it by $10. And so if X is 1, right, you increase it by $10 one time. If X is 2, you increase it twice, right? And of course, so forth. Okay, so X is the number of times you increase the price by $10. Okay, so with that said, right, let's go back and read the problem. For sentence number 2, it says, for each $10 increase in price, so each $10 increase in price, I'm going to say plus 10x simultaneously, right? One less system per month is sold. So we'll call this 1x. Okay, so as I'm increasing the price by $10, one less is sold. So this is your revenue function. Okay, R is a function of X. And now you have just one equation. You don't need to get a second equation. Everything's a function of one variable, and you just need to find the max. Okay, so find the max, which is basically the vertex. Okay, so we want to maximize revenue for this particular store, right? So again, this is an intercept form, so I'm going to get the two x-intercepts. 40 minus x is equal to 0. X is equal to 40 is going to be one of the x-intercepts. 200 plus 10x is equal to 0. You're going to get 200 is equal to negative 10x. And x is just going to equal negative 20. Okay, so if these are my two x-intercepts, to find the vertex, it's p plus q over 2. 40 plus negative 20 over 2. 20 over 2, of course, is 10. So is that it? Is 10 my final answer? The store should just charge $10? No, 10 is the number of times, okay? 10 is the number of times I should increase the price by $10, okay? So if 10 is the number of times I should increase the price by $10, the answer to part A, what should the store charge? 200 plus 10 times 10, okay? So 200 plus 100, which is $300. For part B, what is the maximum revenue? Of course, you already know X is 10, is the number of times they should increase the price by $10. Figure out what R of 10 is. Okay, so you already know it's $300 as the price. And multiply by 40 minus 10. Okay, 40 minus 10, right, which is 30. So you get 30 times 300, which is going to be $9,000. That's the maximum revenue. Okay, so R of 10 is just 9,000.